Okay, so the video that we did from last time, I did want to recap a little bit, okay? So we are recording right now for the fact of those who were absent, they can see this. This will not be at public. We're going to quickly go over what the last video should have shown you and subtleties that are very important that I want you to make sure that you have. And you can go through your notes if you want. Alright, Extrema. All they are maximum and minimums. Why do we care? Because in real world we want to minimize certain things and we want to maximize certain things. And the examples that I gave you, maximizing profits, minimizing costs, or minimizing the tumor spreading that's cancerous at a certain rate and understanding what medicine can I use that would maximize that possibility of destroying the tumor or whatnot. Do you understand? So there's many applications for this knowledge, okay? Relative extrema. There were two that we talked about in the video. There were some that were absolute, and this was global. And then there were some that were local, which was relative. These go hand in hand. They mean the same thing, potato, potato. You just know both because in case they ask you a certain thing, you know exactly what it's talking about. Alright, so absolute means, if I'm the absolute max, that's it. I'm the max. I'm the biggest thing around. It doesn't matter if it's local. It says everything on this interval, I'm the max. Now, can I share that Y value max with someone else and still be the max? Yes or no? I can. So let's say that I'm 40 years old. And Ian, he's not, but if he's 40 years old, we have the maximum age in this room. Do you understand? We share that absolute max. So that can happen. Okay, do you understand? Now, relative max. Relative is different. Relative means the surrounding area, the local neighborhood. Okay, so if you want to be the big kid on the block, right? You're the big kid, whatever, muscles on the block, right? Or you're walking up and down the block, you're the big kid on the block. But only in your neighborhood, you're a relative max. But if I said, are you the biggest kid? Are you the absolute max? He still says yes. Yes, that's saying globally. That's saying a bigger interval. Do you understand? It's all revolving about how big is the interval that you're analyzing. All right, so now let's keep going. Looking at this, this was an important word that I was talking about on the video last time. F has an absolute maximum at what? X equals 4. Because it's saying where, when, the time. It doesn't say what it is, it just says where it is, when it is. Now, if I said, what is that absolute max? What would you say? 21. Not 421. You say 21. Because 21 is the height. It's the velocity. It's the acceleration. Whatever it stands for, but that's its value. The y output is the max. Where it occurs is your independent variable x. 4. Do you understand? All right. So let's now go to something that we were looking at on the video that's called a critical point. A critical point is exactly that. It's critical. Something important is happening that we need to analyze. Either the tumor is starting to grow or it's starting to shrink, or the cancer is spreading, whatever it is, or all of a sudden stock went up in this certain stock or this certain mutual fund or whatever, and we want to invest. So critical points are basically telling you, hey, look here, something is about to happen. You should jump into the market or you should jump out because you can either make a lot of money or you better get out before you lose a lot of money. You with me? Now, how do we find that with the knowledge that we have now? Finding the derivative and setting it equal to two different things. What's one? Zero. Yep. What's the other? Undefined. Okay? So right now we should know f prime of c is equal to 0 and f prime of c is also equal to undefined. Two different forms that I can find critical points. You with me? Now, you tell me, how can an f prime of c be undefined? Give me an example. It's a vertical tangent. Is that what you said? Okay, vertical tangent. Good. That's when the denominator is equal to what? 0. What's another way that, yes? Cusp. Good. What else? That's the one I'm looking for. The endpoint, right? An endpoint cannot be differentiable. Why? Perfect. It has one-sided wing. That's it. It doesn't approach from both sides like Noah just said. So what's the shortcut to know about that? It doesn't have wings, if you will. The way we used to draw birds long, long ago, and here's the sun, we're all happy and everything. There's a bird, right? If it doesn't have approaching from both sides, it doesn't have something called local linearity. You cannot take a derivative of some sort. Or, you know what I'm saying? It doesn't have both one-sidedness coming from the left and from the right. Just like a limit did way long ago. You with me? So an endpoint, it can be continuous from one side, but it can't be differentiable because it's not continuous from the other. You with me? Okay. Alright, so let's go now to this one. Minimum at what? X equals 0. Maximum at?
X equals 2.
What did we say the maximum was here? Does not exist, right? It's not possible. Not undefined, because that's like dividing by 0, whatnot. This is not possible. So we just say it does not exist. Why? Because it's an open interval. It needs to be closed. Otherwise, you will infinitely approach a number that you're trying to find its maximum, but there'll be one right above it. When you get there, there's another one right above it, because you're always approaching that number. All right? And then just the same over here. The minimum does not exist. So there are two underlining things that I want you to make sure that you wrote down. What are the two criteria that will guarantee that you'll have a max or a min? Closed interval is one of them. And continuity. Yes, continuous on the interval. Perfect. So closed interval and continuous. Now let me draw some examples and you tell me. I'm going to do it like from this graph. We'll have them closed still. Then I'll come here and then I'll go up and we'll close it like that. This right here, is it a relative max or min? Neither. Because relative needs what? Wings. It needs both sides. An absolute does not need both sides. An absolute can be one-sidedness. Put that in your notes if you don't already have it in your head. Making sense. Relative has to be local of some kind, both-sidedness, or the absolute, it doesn't have to. It could just be one. Okay? So this is neither, right? Neither a relative max nor a relative min. Is it an absolute max? No. Because look at this. I'm talking about this entire graph. This right here, let's look at that. Relative or absolute? Both. Who said that? Good. Both. Because not only is it relative because it has wings and it's the biggest one around locally, but looking at the entire graph, it's also the biggest one comparatively to everyone else. So if you need to write that down as an example, relative and absolute. Max. Okay, so now let's look at this guy right here. Let me highlight it. What would that be? Relative and absolute min. You with me? And then you can come back here and say, well, this isn't going to make sense. It's not. It's first of all, it's an endpoint, so the only thing it can be is absolute. But comparatively to everything else, it's not going to be a max or a min. Do you understand the subtleties now? Okay, so let me see. How about if I drew this function right here? And I said this is an endpoint A, and this is an endpoint B. And y is equal to 3. So let me draw like, here's an x-axis and here's a y-axis. What is A? Nice. Absolute max and absolute min. What is B? Same thing. What would C be? What?
Absolute max, absolute min.
And relative max and relative min. Do you understand? Absolutes are only endpoints. Or they can only be end. Oh, no. Say that again. Relatives cannot be endpoints. That's what I meant to say. Absolutes can be endpoints and the stuff in between.
So relatives can be shared also. Relative maxes can be shared to points also. Like, let's say there's a point.
Yes. You Someone else? Yeah. The A is like right here, my bad. Here's your A, and here's your B. And then this is like, A is equal to, the F of A is 3, F of B is 3. Okay? Now that's a good recall, or recap. Here we go. Very first thing. Your very first theorem is extreme value theorem. And extreme means just that. It means the most extreme, the biggest one, and then the smallest one. Forevermore, what you're going to do in this unit is you're going to identify things called the critical points. Okay? So let's read what we have. If f is continuous on a closed interval, that's important, then f attains an absolute maximum at f of c, or an absolute minimum at f of d. What kind of values are f of c and f of d? Y values. For some numbers c and d, what kind of values are those? X values. Those are my input values in or on this closed interval from a to b. Do we understand? Do you understand what we're reading now? C and D are x values that exist between a and b endpoints. The y values are saying if it's the maximum, it can be the absolute maximum if it's bigger than everything else. You'll see it a little bit more when we start jumping into the examples. Guidelines for finding extrema on closed intervals. This is called the candidates test. And this is how you're going to say it. Per candidates test, blah, 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 blah. You'll see here in just a bit how we're going to do that. To find extrema on a closed interval, we're going to use the following steps. First of all, we're going to find the derivative and look for critical numbers. So immediately, derive and set the derivative equal to what? 0 and undefined, right? So f prime of x is equal to 0, f prime of x is equal to undefined. Good, good, good. Evaluate f at each critical number. This means from endpoint to endpoint. This means between non-inclusive. Don't include them. So if I'm evaluating f on each critical number, what am I going to do when I find these critical numbers? I'm going to plug them into what? What equation? The original one. Because the original one will tell me what was its height, what was its volume, what was its area at that point in time. Do you understand? So here we go. Evaluate the f at each endpoint. Why do we do endpoints? You're right, you're right. Nice. Do you see what he just said? You're trying to see if they're one of the extremes, but more important than that, why would we do endpoints? Because it's the same as critical numbers. Right? What's the oh, that's wrong right there. That's wrong. I didn't mean to write 0. Undefined. They're the same as critical numbers. There you go. The least of these is the min, the max is the maximum. Now, basically this is what I'm doing in a nutshell. This is A, this is B. If I were to list it out something called the candidates test, so per candidates test, what I'm going to do is find the important numbers. I already know 2 of them. What are the 2 that I know? Negative 1 and 5. Why are they important? Because their derivative is what? Undefined. Undefined, right? It's a critical number. Let's find the ones that exist in between negative 1 and 5. How do we find the ones that are existing in between negative 1 and 5 that are important? So what equal to 0? The derivative. Derive it, set it equal to 0, but also set it equal to what? Undefined. So here we go. I'm going to differentiate the derivative or the function, and I get anyone? 6x minus 24. What's the step that you think that I want you to do right now? For other problems that are coming, what's a good habit? GCF. GCF. Here we go. X minus 4 GCF, set it equal to 0. The reason of being from algebra 2 that we used to do, 6 is equal to 0, and x minus 4 is equal to 0, x is equal to 4, and what's my answer here?
It's going to be...
No solution. There's no x. There's no x equals anything. I don't have an x, right? Does 6 equal 0? No. So that's no solution. If it was 6 equals 6, then it'd be infinite solutions. You understand? There's no x is my point, so you can't find a 0 for that piece right there. So x is equal to 4. I will add that right there. I have the endpoints, and I have all the important ones in the middle. Can I set this equal to undefined?
No.
No. There's not a rational function of some sort. Okay?
Wait, when would you set it equal to undefined?
When there's a rational function, then I can set it to the fact of setting the denominator equal to 0. And that would say, ooh, I'm going to have an undefined piece. You understand? Like we've done before in other regards. So, let's go a little bit back to what we've done. Using a tool, because sometimes you won't have the calculator, I'm going to put 3, negative 24, and negative 1. And let's go ahead and put negative 1 in first. So this is 3, negative 3, this is negative 27, this is positive 27, so this is 26. Do you agree? What did I just use? What is that called? It's not division. Synthetic substitution. Synthetic substitution is used to give us a y value output, not necessarily trying to find 0 as the output. Okay? So doing it again, for those of you who are practicing, or you can use your calculator, if I put 4, again, into the main function, what would I get as a y value output? Say it out loud if you already got it. Yep, negative 49. All these are y values from the position function. What's the next one? Yep. So what's the minimum there that you see? Negative 49. You'll write it like this. Absolute min equals negative 49 at x is equal to 4. Absolute max, hold on just a bit, is equal to, this is negative 49, 26 at x is equal to negative 1.
Are you trying to do it the at symbol or is it just...
That's an at symbol.
Okay.
It's an at symbol. Or you can write AT if you want. Okay? Yeah, my bad. That does look kind of like an E. That's an at symbol, guys. Another way that you could write that. The reason why I'm going to show you is because you might see it in pieces that they give you. F of 4 is negative 49. F of negative 1 is 26. What's the danger in that, though? What? You're listing points and not necessarily being as exact descriptive of telling me that the max is not 4. Or sorry, the min is not 4. The min is negative 49, occurring at 4. It's subtle but huge, guys. This was makes or breaks you when it comes to free response questions. Understanding those subtle, important, descriptive pieces. Alright? We good? So, per candidate's test, my answers will be this, because all I did was evaluated the endpoints as important numbers and the ones in between that are equal to 0, the derivatives equal to 0 and undefined. Alright, so let's do another one. Alright, so, anyone, what's the derivative of this guy? 18x squared minus 24x to the third. Perfect. And what do you think I want you to do at this point? GCF what? 6x squared. Good. 3 minus 4x. Now, I should be able to see the zeros right now. The first 0 is what? 0. The other 0, without rewriting or doing algebra, do it in your head, would be what? 3/4. So when I list out per candidate's test, I'm going to list x, f of x. And if I wanted to go least to greatest, just so that you can get in your head of how this is arranging, what's the lowest one that I'm going to write? Negative 1 and then 0, 3/4, and 2. Now with the calculator, or you can do it by hand, go ahead and do that and I will catch up to you, okay? So let me pause this real quick. Hold up. I'm going to show you something right now with the calculator. Good time to show you with the calculator, because some of you are looking at that 3/4 and you're probably thinking, yeah, I'm not doing synthetic division with that, or synthetic substitution with that. This is how you're going to do this. Ready? Go to your calculator, press home, 2 for my documents. From here, it's menu C, OK, to clear your calculator, okay? So from here, what I want you to do is press from the home key, new document, no to unsaved changes, and you're adding a calculator. Right now, you just added a page on this document that its default mode is in radian mode. You ready? I'm going to show you on how you can use something a lot faster than the prehistoric table that y'all been using with those TI-84s. Okay? Instead of putting it into the graph and trying to get numbers from the chart, do it like this. We have, haven't we? Okay. I'm going to put 6x cubed, and it's going to be minus 6x to the 4th, and then it's going to be plus 5. I just typed in my function, and now I'm going to store it as a function. But I can't store it as f. I got to store it as what? F of x. Yes, f of x. Here we go. How do we store it? Control vars, where that store blue writing is, as far as storing it, and I'm going to store it as f of x. And you're going to notice when you now put f, it's going to be bold, because it's already stored as a function. And I can put, all right, f of, what do we have? -1 is that. F of 0 is that. F of 3/4 is that. And you can, excuse me, let me put control divide, and there's a decimal for you. So put 5.63, what? 5.633. And then the last one is f. If you need to go back, guys, either ask a neighbor or watch the video later. F of 2 would equal -43. So when I come back, here's the chance. Chances are, if it's with fractions, you're going to be able to use a calculator. But please don't dismiss the fact that some of these you will not have the calculator, and you do have to do by hand, okay? And I'm going to show you how to do those here in just a bit. -7, 5, 5.633, -43. Ready? Absolute max is what? 5.633 at, perfect. Absolute min equals -43 at x is equal to 2. Pretty easy so far, right? All we're doing are looking for absolute mins and maxes. I haven't said anything about the relatives. Candidates test. All right, let's do now these, and we'll do these together because I want you to see on how you'll do it by hand. Okay, so no calculator for these. All right, I see absolute min and maxes. I see endpoints, so immediately I'm going to go to candidates test. That's my go-to. That's my memorized process already. Okay, so first of all, let's derive. So what's the derivative of what you see right here? 2 what? 2x to the -1/3. Good. 2x to the -1/3 hasn't been that long. Minus 2. We're going to set it equal to 0. That means I'm going to move this 2 over. I'm going to jump a little bit, and I would get to this spot. Do you agree? And some of you might actually rewrite this and rewrite it as x to the -1/3, which is this. Right? X to the -1/3 is like moving it downstairs and saying x to the +1/3. Well, x to the +1/3 is the third root of x. Here it's easier to see. If I flip-flop these, it's going to help me solve for x. I'm helping you with algebra manipulation by hand of what you'll be seeing soon. So the cube root of x is equal to, what's 2 over 2? 1. So now think, what can x be? Only 1, right? Can't be negative 1 because 3 is what? Odd, yes. If it was an even, it would give that positive value? Yeah, okay? So x is only going to be 1. This is my critical point that exists in between negative 1 and 8. Are there any that we can set equal to undefined, if you will? In this regard that you see? No, this is going to be the only one. So we'll have negative 1, 1, and 8. Candidates test. All right, here we go. Negative 1 raised to the power of 2/3 is going to be done first. Now, if you don't know this, some of you might have forgotten it, very important. It's the same as that. It's the same as that's not what I meant. That. Multiplication doesn't have any order. True or false?
True.
True. So looking at this, I'm going to do the root first. So follow me. Here we go. If I put negative 1, what's the cube root of negative 1? Negative 1. Okay, now square. 1. Now multiply by 3. 3. What am I going to do there? Since my negative 1 is 3 plus 2, so 5. And 6. You see how we're doing it? And these are the ones that you're going to do by hand without a calculator. You won't have a calculator for these. Let's do the next one. Put 1 in. So the cube root of 1, 1. Squared, 1. Times 3, 3. Minus 2, right? Not plus 2 this time. So you get 1, right? So what's my answer? 2. Now here we go. Some people will look at 8 to the 2/3 and they will say 8 squared is 64. The cube root of 64, and they're like, ugh. Because sometimes you have 728 and all kinds of other bigger numbers. Don't do that. Cube it or cube root it first. What's the cube root of 8? 2. Square it. 4 times 3, 12 minus 16. Negative 4 plus 1, negative 3. Look how fast you're doing that, and I want you to be doing it that fast. Without a calculator, okay? All right, what's the absolute max? 6 occurring at x is equal to negative 1. Absolute min, negative 3 occurring at x is equal to 8. Easy, right? I told you this was easy. You'll see there's more stuff being added to it soon. Here we go. Let's see what you remember from this. Kyle, what's the derivative?
2 sine x. Is this right now? Wait, no. Isn't this the equal to thing? What's it called?
It's all right. You were right when you were saying the derivative.
Oh, was that really? No, I was fine. Let me write it.
Guys.
Is it 2 sine x and then negative cosine x?
No, almost.
2 sine x.
Cosine x, right? When we're walking forward or deriving, the derivative of sine is a positive cosine, right? The derivative will only be negative when I'm trying to take the derivative of something that starts with what? Co. Cosine, cotangent, cosecant. Then it'll be negative something, right? Alright, so I'm going to put 2 sine of x, chain rule, cosine of x. Anyone? What's the last part? Minus sine of x. Now, what would I probably put here as far as, what's the next step? GCF. Okay, so GCF what? Sine of x. So I have 2 cosine of x, what? Minus 1. So I have 2 things. I have sine of x is equal to 0. And I have cosine of x is equal to what? 1/2. Are we good? Go for it. So let me catch up to you. Unit circle. The sine is what value? Y. So when is the y value 0? 0, pi, and 2 pi. That's exactly where I'm going to stop. right? Inclusively. So this one is 0, pi, and 2 pi. Now let's do this guy right here. When is the cosine 1/2? Pi over 3 and 5 pi over 3. Good, so we didn't remember, or forget it, good. Pi over 3 and 5 pi over 3, because we're only looking at x's that are what? Positive. Okay, so listing all these out, we have 0, pi over 3, pi, 5 pi over 3, and 2 pi. A bunch of candidates, and we're going to see which one's the max, which one's the min. Plugging in the calculator, and for sake of time, if I plug these into the original, not this derivative, but the original, and using that way that I stored the function in the calculator before, I can just do f of 0, f of pi over 3, so on and so forth, and I get the following. 1, 1.25, negative 1, 1.25, and 1. And this goes back to what Ian was saying earlier. What are my absolutes? My absolute maxes are 1.25 shared at x is equal to pi over 3 and plus 5 pi over 3. And my only absolute min is negative 1 at x is equal to pi. Okay? Per candidates test. Recap. Per candidates test are only absolute max and mins. I will evaluate them everywhere where the derivative is 0 and undefined, and the endpoints no matter what. Okay? Alright, so let's go to the mean value theorem. Okay? Mean. Otherwise, the average. Okay? So the mean value theorem says if a function f is continuous on a closed interval and differentiable on an open interval, why differentiable on an open interval? Why that subtle change? Because the endpoints are not differentiable, they're what? They're undefined slopes, right? Okay, so if it's that case, these are the two rules that are holding, then there must exist some value c on a to b to which the following is going to happen. Now, if I'm looking at this and I want to know some value c, and I'm looking for the mean value theorem, it's saying the average rate of change is going to equal something called the instantaneous rate of change. Okay? So I'm going to put secant slope is equal to the tangent slope. What could the equation be? And I can write it 3 different ways. You'll come up with an equation. Let's come up with the tangent slope. How can I write the tangent slope on what it's asking? How do you think? It says then there's at least one number c. So it's like here's A, here's B. There's one c somewhere in the graph where the slope doesn't have to equal 0. Here we go. F prime of c. This is f prime of c. Instantaneous rate of change is f prime of x. You've been doing it. It's the derivative. It's the slope. F prime of x. So f prime of c is equal to, let's come up with the secant. Let's come up with the secant to where we're talking about a and b. How can I do that? Say again? Sorry. Anyone else want to volunteer? How do I show a secant slope between a and b? How do you do that?
Like point slope.
Not point slope.
Yeah, that's what the slope.
So y2 minus, so that's 2 points for that one. y2 minus y1 over x2 minus x1. If I drew a graph, and let me draw the graph like this. Here's A, and the graph went up like this, and then here's B. You with me? And I drew a straight line. This line that I just drew, let me highlight it in purple, is called a secant slope. This has a secant slope. And how do I show that? y2 minus y1 over x2 minus x1, which you learned and spent probably years in Algebra 1 going over and over and over again. Here we go. But we're going to do it different. We're going to put f of b minus f of a. And we're going to put it over b minus a. F of b is y2. F of a is y1. And b is x2 and a is x1. Do you understand? I have endpoints that when I let's put a as 2. If I put 2 into the function, I'm going to get a y value at 2. That y value would be f of a. So y2 minus y1 over x2 minus x1. Another way that I could see this possibly on a question is f of b minus f of a is equal to f prime of c times the quantity b minus a. What did I do to get that? Just multiplied b minus a. Got rid of the denominator. The last one is b minus a is equal to f of b minus f of a over f prime of c. 3 different ways to deal with the same idea of mean value theorem. Okay, you're going to see what this means here in just a bit. Let's look at something called Rolle's theorem first, though. How many conditions do you have in the mean value theorem? 2. Very important. You might want to write that down. Only 2 conditions. Let's look at something called the Rolle's theorem, where immediately you'll see 3 conditions. Okay? First 2 are the same. It's continuous between the endpoints, means I drew it without picking up my pencil, and then now it's differentiable everywhere in between, just like we said, because we cannot have derivatives on endpoints because they're undefined. There's no wings, if you will, no both one-sidedness. But here's the last thing. F of a is equal to f of b. Okay? So if I go back and I create this, and I say, okay, I knew that mean value theorem was this. And if I say these 2 are equal to one another, what is Rolle's theorem trying to say? F prime of c is 0. F prime of c is 0. Not undefined. Only 0. Okay? So f prime of c is 0. Well, let me go ahead and write that over here. What am I doing? F prime of c is 0, which denotes f of a is equal to f of b as long as what? That's not what I'm looking for.
They're not at the same point.
Wait, what?
A doesn't equal B.
Good, that's what I was looking for. As long as a does not equal b, right? What else? The last one could be just showing that f of a is equal to f of b can also be 0. Because 0 minus 0 is what? 0. Does f of a and f of b have to equal 0? No. They just have to equal what? Each other. Because when you do subtract it and set it equal to the derivative, then you get the 0. Okay? Alright, so now let's work on some problems to see what we're talking about. Show that the conditions. Alright, here we go. When you see show, guys, it's the same as prove. So you're going to do a proof like you did with intermediate value theorem. It's going to be a little bit easier now, like I said before, because you've had exposure to this. Prove that if the conditions of Rolle's theorem are met, then there's basically going to be a C that's guaranteed. Okay? So there exists a C somewhere in between -2 and 3 that the Rolle's theorem will apply. You good? All right. What's first condition? Perfect. F of x is continuous on that. Do I need brackets or parentheses, what I just wrote? brackets. Good. Know the difference and know the subtleties, and you do have to have them. Next one is what? Differentiable, right? What? Open. So f of x is differentiable on -2 to 3, open. Again, because we can't derive endpoints. The third criteria is what? F of -2 is equal to f of 3. Let's check it real quick. Okay? And you can do synthetic division if you want. If I plug in -2 into it, I'd get 0. If I plug in 3 into it, I would get 0. The fact that there's 0 shows that it's going to be guaranteed as far as the Rolle's theorem. True or false? False. The fact that they're equal shows that it's going to be Rolle's theorem. Not because they're 0, because they're equal. Because then when you go back to what we showed before, this part right here, if they're equal, that part's going to be 0. Because you're subtracting itself. Okay? Again, with that stipulation, as long as the denominator is not 0. Alright, so here we go. The rules hold, so the theorem will hold, and therefore it's going to guarantee that there'll be a C on -2 to 3. So here we go. Theorem holds. Therefore, there must, remember this stuff, exist a C on -2 to 3. We've already talked about why it's C, right? Why C is so important, right? Versus X. C is specifically saying on a certain interval, where X could say everywhere. Okay, that's why we use C, but they're both X values. On -2 to 3, where what? Where f prime of C is equal to 0, right? F prime of C is equal to 0. Why 0? Because f of A and f of B are what? Equal. Okay? So, where f prime of C is equal to 0. So let's derive it. Here we go. F prime of x is equal to 2x minus 1. Therefore, f prime of C is equal to 2c minus 1. It goes without saying. We're just showing it with c values. And then when we solve this, after setting it equal, anyone, what am I going to get for c? C is 1/2. Is c being positive 1/2 in between -2 and 3? Yeah, so it works. Sometimes it won't, but in this instance it works. Theorem holds. Therefore, there must exist a C on -2 to 3 where f prime of C is equal to, and we solve for it. Done. If any one of these fail, you can stop immediately. Remember we did that last time? Theorem does not hold because, let's say this was not differentiable everywhere. How could we say that that wasn't differentiable everywhere? If there's a cusp, not a horizontal tangent, a vertical tangent. Those are the only two. Right? Because it wouldn't have jump discontinuity. Why? Because it'd be continuous. See how it's getting a little bit stronger as far as revisiting this stuff and now doing it with mean value there. We're not trying to find a y value that exists between two to show that there'll exist an x value in between two x's. We're trying to show that there existed an x in between two x's where the derivative, its slope, is equal to the tangent. How does that look? Well, let's look at this graph. Let me basically give it like this. Let's say that I had a graph that was from -2 to 3. And it's not this particular one. And it looked like that. Is it continuous? Is it differentiable everywhere on the open interval?
Yes.
Yes, because there's no cusp or vertical tangents, right? So therefore, the very first rule that I would do is find its secant slope. F of B minus f of A over B minus A. We call this a secant that goes between those 2 points. Secant line. It has a slope. You with me? It will be equal to f prime of C. And in this case, maybe I shouldn't go back to this example. This is mean value theorem that I'm showing you right here. So don't correlate it with this example at all. I'm just showing you a picture of another graph. And I'm saying, guys, there exists a C. From here to here, there exists a C where its slope, its tangent slope, is parallel to that. How many C's do you see? Not infinite.
One. Is it the one that
No.
Two.
Two.
two that the two
Ready?
crosses?
Let me copy this, and then right there. Let me copy this, and then right there. So here's one right here, and here's one right here. So the C's are whatever this value is, and whatever that value is.
So it's got the- okay, right.
It's where the tangent slope equals the secant slope. Now you want to know the difference between that and Rolle's theorem? The only difference is that on Rolle's theorem, the secant slope is 0 every time. If and only if f of a is equal to f of b. So it'll look like this. Here's my y value, here's my y value. And it does anything it wants to in the middle. You with me? This slope is what? 0. So if I copied it, I would have it here, 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 and here. Why is that important? Because those are possible relative max and relative mins. You with me? Alright, so here we go. Relative max, true or false? True. Relative min. Okay. Let's now do something similar. Relative max. True. The slope does not have to be 0. Do you understand? It's still a relative max. It's still the biggest kid on the block in the neighborhood, basically in the surrounding neighborhood. You ready? This one is what? Relative min. Also the absolute, right? Do you understand the subtleties? Okay. Now let's go to, we're almost done. We're almost done. Give it, say again? Where? It is a cusp. Which one can you not have a cusp? That's what we're talking about. Yeah. What was I? Did I say something wrong?
It's not differentiable.
It just means that. Oh, okay. We were asking earlier, how do we identify those cusps? We can identify them because they're non-differentiable. F prime of c is equal to undefined. Another, and those two forms that we could see that would be if it was a relative max or relative min, the way we just saw. What's another way that we can show undefined? We talked about it. We said it earlier. A vertical tangent. But see, this one, that's a good timing of that question too. Now, right there, what's the derivative right there? What's undefined, right? Could it be a critical, is it a critical number? Yes, it is, because it's undefined. Yeah, I don't want you thinking critical numbers are this and that, or maximins, and that's why I liked her question and the timing of it. I don't want you thinking relative max and relative mins are the only critical. This is critical too. Because what's happening here is, we'll get into it now. I'm not going to jump there quite yet. But it's correlating the first and second derivative at the same time. Okay, but right now we're just talking about the first derivative, so we'll chill. Alright. Come on, man. I get excited when y'all get it. Alright. Given the function 3 minus 5 over x on the interval from 1. So let me highlight this. 5. 1, 2, 3, 4, 5. We're looking on this interval, so that means from here to here on the graph. You see it? Alright. The graph of f of x is shown on the right. Visually, what is the MVT trying to find and draw it in? Okay? Here's my endpoint. Very first thing when I see MVT, I draw a secant slope. So I'm going to jump the gun with this as far as already kind of showing you an example with this. Visually, the MVT is trying to find a C that exists between 1 and 5, right? Where f prime of that C would equal what? Which is what? Which is 1. Look at this right now. What's this? 1, negative 2. 5, 2. Here we go. F of B is 2. Minus f of A. Minus a negative 2. Over B minus A. You see it? So we'll get what? 4 over 4, which is 1. It makes sense. Up 1 over 1. Up 1 over 1. It's going through the corners. You see it. You've done it since algebra 1. Okay? So visually, what is MVT trying to find? It's trying to find a C on 1 to 5 where f prime of that C would equal 1. How many do you see? Just 1, right? And let me use a cheating shortcut. It would be right there. Whatever that is.
Precise.
Right? I'm not forever. Alright? So that C value, whatever it is, it's going to guarantee that there's my answer. Why? Because it's continuous and it's differentiable. No cusps, no vertical tangents. Going back to what we were saying from the slide before. Okay? Good, good, good. Alright, so how can I solve for this? Derive, right? Here we go. What is the derivative of that? Wait, what? 5 over what?
5 over x squared.
5 over x squared. Here we go. F of x is equal to 3 minus 5x to the negative 1. Rewrite it. Why did I bring that x up? True, but why did I do that on this problem? Because the top is a constant. Right? The top is a constant, that's why I brought it up. Remember? And if there was a variable up top, we wouldn't do that. Alright, so derive that now. We get a positive 5x to the negative 2. Otherwise, f prime of x is equal to 5 over x squared. We're going to set this equal to what? Anybody? 1. 1, not 0. This isn't rows because f of b does not equal f of a. We're setting it equal to whatever the secant was. In this case, 1. Flip x squared and 1. So x truly is what? Plus or minus the square root of 5. Okay, a lot of people miss that. They don't say that. Very few people do that. Someone do that with the calculator for me, please. What is the square root of 5? 2. Please, 3 decimal places. 2.236? Alright. Pretty close. Look at that. My picture was kind of close, right? Yeah, sort of. Alright, here we go. There's only one answer, though, even though we have 2 up here. The only answer is what? Positive, because that's the only one that exists on the interval that we're observing. All those subtleties should be coming together as far as why were we needing to show all these little parts. You know what I mean? They tie in together as far as showing how certain things will exist. Okay? Now, let's do our example. I will leave this open-ended. I do want you to work on it. I will assign homework for web assign. And I will add puzzle the next unit, or the next notes, because the next notes aren't too bad. Next day's notes. Yes, you still have CFA, so please come prepared. The homework I will post later on this afternoon in regards to what you learned just now. Okay?
Do the CFA on Friday?
Yes. What were you gonna?
When's the homework due? Friday?
Friday. Yeah. Okay, you ready?